Okay, this is actually take 2, so you're going to see some things that are already written. It'll just take us less time this way. So today we're going to be talking about absolute value equations and inequalities. But first we're going to remind ourselves as to what absolute value is. Absolute value is the distance of a number from 0 on the number line. So we are just looking at a distance, and distance can never be negative. So here we're looking at the absolute value of -7. Remember, we're flanked here by these two vertical lines. The absolute value of -7 is 7, and that is just telling us that -7 is 7 numbers away from 0. Similarly, if we are talking about a +18, the absolute value of a +18 is also going to be a positive number of 18 because it is a distance of 18 numbers away from 0. So that is what our absolute value is. Now, when we look at the absolute value of variables, let's say we have the absolute value of x equaling 3. Well, we now have to realize that either 3 or -3 could be our answer to this problem, because either one of those inside the absolute value symbol will give us an answer of 3. But so now we're going to move on to more of a one-step problem. We could even do this with two-step. We're going to start pretty simple, and we're going to be looking at the absolute value of x minus 2 equals -1. The way we're going to start is we're just simply going to add 2 to both sides. Okay, what this will leave us with is the absolute value of x equals, and +2 with a -1 is going to equal a +1. Okay, now the absolute value of x equals 1, so x therefore can equal 1 or -1. It can equal both of those answers. Let's look at another one. I realize these are simple. We won't spend a lot of time on them. But let's go more to a two-step problem where we have 4 equals 3 absolute value of w minus 2. Now, just like with all of our other two-step, we're going to undo our addition or subtraction first. So we are going to add 2 to both sides. This will give us 6 equals 3 times the absolute value of w. Just like our other equations, we need to get this 3 away from our w. So we are going to undo multiplication with division, and we will use the division property of equality. So we will do the same thing to both sides. 3 divided by 3 is 1, leaving us with the absolute value of w equal to 6 divided by 3 is 2. And so we know, therefore, that w can equal 2 or -2. Okay, so pretty simple stuff. But we now are going to expand what is inside our actual absolute value symbol. And that makes it a little bit more difficult. So I'm going to start here. We're going to look at a problem that is c minus 2 equals 6. Well, now, because we understand that what we're looking for is a positive answer, of course, and we have this absolute value equation, we are going to have to figure out a couple of things that are different with c. So the way we're going to solve this is we are going to say c minus 2 is equal to 6, but we are also going to say that c minus 2 could be equal to -6, because we know that if this answer came out to -6, the absolute value of it would equal 6. So we have to solve for both of these equations. So adding 2 to both sides, I come out here with c equals 8, and adding 2 to both sides here, I come out to c equals -4. So I have two answers. Now what I'm going to do is I'm going to check both answers to make sure that these work. So first, my 8 minus 2 equals 6, and this comes out to the absolute value of 6 is equal to 6. This is correct. Now I'll come over here and I'll say -4 minus 2 equals 6. I'm going back to my original equation now to check, and this comes out to -6. The absolute value of -6 equals 6. Is that correct? Yes, it is absolutely correct, because the absolute value of -6 equals 6. So let's go ahead and do one more problem like this. Let's do 7D. The absolute value of 7D equals 14. Let me move this so you can actually see what I'm doing. Okay. And I will make this 7D equals 14, and 7D equals -14. If I do my division to both sides, D is equal to 2 here, and D is equal to -2. Now I will go ahead and I will do my check, and I will say the absolute value of 7 times 2 equals 14, and this becomes 14, oops, doing that wrong, equals 14. That is correct. And here I have 7 times -2 equals 14, going back again to that original equation, and this comes out to -14, the absolute value of -14 equaling 14, and that is also correct. My mouth was getting all caught up on 14. So these are your equalities. Now we're going to talk about the inequalities. Now the inequalities, still very easy, maybe a little bit more to think about, and so when you're doing problems, you're going to want to refer back to the examples that are in the book. I always do different examples for you so that you have a variety. We are going to, I'm going to start with the rule, because I think that if we get to know the rule, it makes everything a lot simpler. So our rule is, if the equality is in the form of A is less than B, okay, and B is greater than 0, okay, then we will solve this as -B less than A less than B, okay? And if A is greater than B, and once again B is greater than 0, then we will solve A less than -B, or A is greater than B. Okay? So we are going to follow that throughout all of the problems. So it's just more of a matter of remembering our rules so that we know how to handle each one of our problems. So let's start with, let me move this down. We'll start with a problem that is W plus 2. The absolute value of W plus 2 is greater than 5. Okay, now if we look back to this, where we have the our variable expression being greater than B, then we see that we're going to be using this technique here. So what that's going to do is give me W plus 2 is less than -5, or W plus 2 is greater than 5. Okay? Now, I'm just going to go ahead and solve this. And so W is less than -7. Here's this. And this is going to be W is greater than 3. Okay? And, of course, we've just finished graphing a lot of these. -7. We've got to get a 3 up here. -6, 5, 4, 3, 2, 1, 0, 1, 2, 0, 1, 2, -6, -5, -4, -3, -2, -1. Okay, so W is less than -7, going this way, and W is greater than 3. It's like graphing our ors rather than our ands. Okay, so pretty much that is really all you need to know. If we are doing, let's say we are doing the absolute value, I'll come down here, I think I should have enough room, 3 minus R, absolute value is less than 5, oh, another 5 answer. Now what we're looking at is -5 less than 3 minus R less than 5. Oops, don't need those in there, sorry, didn't need those. Okay, I'm going to subtract 3 from here. Okay, this is going to give me -8. It's greater than less than, I'm jumping the gun and I apologize, -R. I know what I'm going to do next, and so so I was all prepared for it. I'm going to multiply everything times -1 because notice I have a negative variable. So this becomes 8 greater than R greater than -2, which when written properly is -2 less than R less than 8. And I think that we all know our graph would look more like an and, so it would be, well, let's go ahead and do it. I'm just always afraid my video is going to stop. So my answer there, again, was -2, I think, less than R less than 8. So my graph, did you see that? I didn't even bother to use a ruler, and I do apologize. I'm always saying ruler, ruler, ruler. Okay, open circles, and it's going to be everything in between -1, 0, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, and so, oh my goodness, you can't even see that, and it was lovely. Not really, I didn't use a ruler. So anyway, this is going to be our solution set for this. What I do want to mention is that had this been, you know, we could have done the same thing with equal to aspect, and then we would have just been filling these in. So so I'm using less than and greater than, but less than equal to, greater than equal to also follow the same pattern. So that is it. Hopefully it all kind of makes sense, and so good luck with it.